In this video, let's see how our error range from 0 to 1 becomes minus infinity to 0 in a very intuitive manner. So let's get started. Let's start with a very interesting topic called inversion. And inversion is nothing but a reflection along this line y equal to x. So for example, the inverse of this point is here because it's just a reflection along this line, and similarly the inversion of this point is there. Let's take another example. The inverse of this point is here and vice versa, and if this is y equal to 1, then this is going to be x equal to 1. Let's take a little more complex example. The inverse of this line is going to be here, and if this is y equal to 1, then this is going to be x equal to 1, and if this is x equal to minus 1, then this is going to be y equal to minus 1. So you can imagine that this line is parallel to the mirror, and the reflection of this line is also going to be parallel to the mirror, and vice versa. Now let's take a slightly more complex example. If we draw a line here, then the reflection of that line is going to be here. And if this is y equal to 1, then this is going to be x equal to 1. And if this is parallel to x-axis, then this is going to be parallel to y-axis, because this is symmetric along both x-axis and y-axis. So if you see like that, then you'll see that this is just a mirror image of, these are mirror images of each other actually. Let's see something more complex. If you draw a curve like this, then the reflection of this curve is on this side. Like, spend a moment to think about how this is a reflection of this, right? So if we extend this curve upwards, and if we extend this to the right, like this, then these curves are also reflections of each other, and that's why they are inverses of each other. Now, since you've got the idea, I'm going to get rid of this mirror, and I'm going to get rid of this straight line and this straight line, and just going to keep the curves. So this curve is a reflection of this curve, and that's why they are inverses of each other. Now if you just focus on the top curve for a while, that reminds us of a to the power x curve, and this bottom is nothing but a reflection of that a to the power x. We'll talk about this relationship a little more. Now if you draw a tangent here, and if you make that tangent equal to 1, then this curve becomes e to the power x, as we saw a few videos ago. And since the tangent here is 1, the reflection of that tangent, which is going to be at this point to this curve, is also going to be 1. So this is a reflection of this curve becomes a reflection of e to the power x. Now this curve has a very fancy name. This curve has the name of natural logarithm. So this is how a log is defined. The log is defined as the inverse of e to the power x. Let's focus on just this log curve for a while. So if you look at this carefully, when x equals 1, y is equal to 0. And when x is 0, y is minus infinity. And this is exactly the relationship that we want for our error, right? This is the relationship, and this is exactly addressed by our log curve. And that is how we are going to manipulate our machine to find the log error instead of the actual error. So for instance, if you want to find the error associated with this point right here, then we are going to find the log of this distance, which is the error, and that is going to give us a large negative value, of course depending on how much this is, but that is going to manipulate our machine, and the machine is going to come up with the correct sigmoid rather quickly. In the next video, we're going to talk a little bit more about bringing together all that we have learned so far.